In today's Python statistics video, we are going to be taking a look at the Kruskal-Wallis test. What we're going to do is go over a little bit of background information behind this test, and then we're going to jump through a few different examples, including a manual calculation, and then some shortcuts that we could utilize with SciPy. So with that out of the way, let's go over a little bit more information about this test. All right, so a little more information on the Kruskal-Wallis H test. So this is also known as the one-way ANOVA on ranks. It's a non-parametric test to compare three or more independent groups. It's useful when the data does not meet the assumptions required for the one-way ANOVA. This could either be the normality or the variances. And you can test both of these with either Shapiro-Wilk with normality and variances with Levene's test. I have both of those on the YouTube channel as well, so I'm not going to go in depth on each of these, so you can check out those videos. But I will be going over some SciPy shortcuts for these within the coding side of the video. The data for the Kruskal-Wallis has to be ordinal or continuous, but does not have to follow that normal distribution. And this is going to be based on ranks rather than actual data values. The null hypothesis, the distribution of the groups are identical. Alternative hypothesis, that at least one of the groups' distribution differs from the others. The Kruskal-Wallis test does not specify which groups are different, only that there is going to be a difference. So each observation is ranked across all the groups. Ranks are summed for each group. Test statistic H is calculated by using the rank sums of the group sizes, and H follows the chi-square distribution with k-1 degrees of freedom, where k is the number of groups. All right, suppose we have three groups representing three different four-seam groups. A four-seam is a type of a fastball in baseball. There's going to be movement or break on your fastball in inches. So each of these three different grips over here determine the groups. Group 1 has 10, 15, 9, and 8. Group 2, 7, 14, 12, 13. Group 3, 5, 10, 8, 6. We're going to make an assumption that this data set does not meet the requirements for the one-way ANOVA, and alpha is 0.05. Again, I'll show you a little bit later with SciPy how we can do Shapiro and Levene. All right, so combine all the data and assign the ranks. So we're going to go through that lowest to highest. If there's any ties, you do the average. So these are the ranks over here, right? 1 through 12. Then we have each of these ranks for the groups 1 through 3. So you can see 10, 7, 5, 15, 12, 9, 6, 8, 4.5, etc. Right? Then we have to sum the ranks for each of these groups. So you can see group 1 is 30, group 2, 33, group 3 is 15. Then we apply the formula. Capital N is total observations. Smaller n is the number of observations for each group. We plug into the formula over here to the right. So it's actually not super complicated, although it looks a little bit, right? And we get a H value of 3.695. Then we have to find the degrees of freedom. This should say df equals k-1, not minus. Small typo, but regardless, degrees of freedom is going to be 2. And we end up getting a p-value of around 0.16 in general. And since the p-value is greater than the significance level, we fail to reject null hypothesis. This indicates there's no statistically significant difference in movement across the different pitching grips at the 0.05 level. All right, with that out of the way, make sure you have a Python notebook ready to go, and we're going to start coding. Let's get started. So what we're going to do over here is we're going to say import numpy as np, and then from SciPy.stats import. First we'll do a Shapiro, then Levene, Kruskal, and also rank data. And we'll be using rank data with our more manual example. And also what we want to do is set our alpha value for the video. I'm just going to say alpha equals 0.05. And we're off to the races. So for our first example, let's take a look at our manual calculation and how we do that. So example 1, manual calc. And what we're going to do is we're going to create our three groups. So I'll say group 1 equals 10, 15, 9, and 8. Great. Then we have group 2 equals, inside over here we have 7, 14, 12, and 13. And then we have group 3 equals 5, 10, 8, and 6. And just remember, next example, we'll be looking at Shapiro as well as Levene. We're skipping it for this one. Okay, so we have these over here. First thing we're going to do is we want to create groups and then pass all of our groups inside over here. The easiest way to combine all these, and we'll say group 1, group 2, and then group 3. All right. And then what we're going to do, and just to show you what this looks like, I'll just print this out. Right. We have each of these embedded inside. So that makes sense. Okay. So what we want to do is we want to flatten all of our data right now and still have these group labels. So let's do that. The easiest way I think we're going to do this is through enumerate. And I have a video on enumerate. So if you want to check that out, awesome. If not, just copy this line of code. This is probably going to be the most complicated line of code in this video. So NP array, and inside over here, we have another set of parentheses, and then we'll have value and I. Then over here, we'll say for I in group in enumerate. We're going to enumerate our groups. And hopefully this isn't in the way. Okay. Then we're going to say for value in group. This all works correctly. All right. And then we just run the cell over here. And just to show you what this looks like, where we have 10, 15, 9, 8, 7. Go over here, right? This all deals with group 1. This just shows a 0 because Python starts with 0. Then we have 1 for next group, and then we have 2 for the next group. Okay, hopefully that makes sense for you guys. Next, what we're going to do is we're going to rank all of our data, and we'll say ranks equals rank data. Then we're going to pass in all data. Put a colon and a 0. All right. Did we not just call all data there? Oh, I didn't have an underscore. That's like, I thought I had all data. All right. So that's going to have all of our ranks. And just to show you what this looks like, the way we can do this too is it splits up these half ranks that tied. So you can see 7.5, 12, 6, 4, 5, 3, 11. So that's what we needed, right? And then what we're going to do is we're going to get our rank sum. So we'll say rank sum equals over here. We'll have this as a blank dictionary. And then what we'll say is for, and we'll have value group, we'll say rank in zip. We'll have over here all data ranks. If group in rank sum group plus equals rank, else rank sum group equals rank. So if inside this dictionary, right, the first time we have each of these groups, right, we start with the first essentially rank over there, and then as we have one for each of these groups, we sum those up. So 7, 5, 12, 6, 4, 5, right? These will all be added up in group 1. Then it'll hit 3, it hits this line, and then it adds these next 4 over, or next 3 over here, it adds into that line. And finally, we start off with 1, which will be this line, and then these 3. Hopefully that makes sense. Now we're going to have all of our rank sums. So to line this up with what we had in our slides, rank sum over here, we'll have 3 groups. And this actually didn't fill up because I didn't run that cell, but now we do. One has 30, one has 33, the other one has 15. And I checked my slides, that's what we had over there. So we are good there. Now we want to find our different lengths. And what I'm going to do, I'm going to change this up slightly from what I had in the slides. So we'll have capital N, we'll see length of all data. And then I'm just going to put K this time for the length of groups. So K equals length, and we'll pass in our groups that. And then what we're going to have to do is pass in this formula for H. Now, chances are if I type all this out, I'm really going to make a small mistake. So I'm just going to copy over my source code and we'll just walk through this. So again, just breaking down the equation that I had in the slides. So parentheses 12 divided by n times n plus 1 times sum. Then over here we have rank sum I, squaring that divided by length groups I for I in range K minus 3 times n plus 1. So pause the video really quick, copy this down. Probably easier for me just to have it like this rather than typing it all out. And once that's good, I'm just going to run this cell really quick and we'll keep going. Let's print out our H value. So print, and we should get around 3.6. We get 357, so I'm happy with that. And lastly, let's just grab our degrees of freedom. And degrees of freedom. You can technically look up the p-value from there. We'll say df equals k minus 1. Super easy, right? Let's end this off on something that anyone could do. Day 1 learning Python 2. So that is going to be our more manual example. I don't expect to do the manual calculation side of things, but you can see how this works with Python. Now I'll show you a bunch of shortcuts that we can use with SciPy. So thank God for these SciPy shortcuts because it turns all this into like line of code. But we're also going to throw in also Levene and Shapiro. So let's take a look at example 2. And we'll say example 2, we'll look at 400 meter times. So we're going to look at 400 meter times between 3 different running clubs. So let's have that data in here. And I'm just going to copy this. So we have group 1, group 2, and group 3. 68, 75, 80, 71, 69, 83, 85, 90, 70, 78, 82, 75, 72, 77, 79, 84, and 65, 70, 75, 72, 68, 71, 74, and 79. Those are going to be the 3 groups. Again, they're just like amateur running clubs, right? We're not looking at professionals on this side of things. Not horrible times, but that's for your 400 meter. Okay. What we want to do first is we want to look at normality. So we're going to use Shapiro. So what I would just recommend is we're only looking at p-value on this one. So we'll say p-value Shapiro. We'll say like group 1. And we'll say this is equal to Shapiro. And inside we just pass in group 1. And what I recommend for you guys is do the classic copy, paste it, and just change these up. So 2 and 3, 2 and 3. And we have all these p-values now. And, you know, we're going to write if else a little bit later, but it doesn't hurt to print these out. So you can print out each of these here. And again, classic, just change up one small thing on this code. And here we go. Look. 0.57995 and then 999. So here's the deal. Our p-value, or not p-value, but our alpha value is 0.05. So we can't reject the null hypothesis in this case because all these are much larger than that. So now we need to take a look at Levene, and that's going to be for the variances. So Levene is just going to be one line in comparison to the 3 since we can pass in all 3 groups into our Levene's test. So what we'll do is p Levene equals Levene. And then inside over here, we'll say group 1, group 2, and then group 3. And let's print out our p-value. Print out our p-value like that. And check a look at this. 0.04, which is under 0.05, would reject the null hypothesis. And we cannot assume that there's equal variance between all these groups, which is awesome because now we can use Kruskal-Wallis rather than a normal ANOVA test, right? So because we don't meet the normal ANOVA assumptions, Levene p-value should be greater than 0.05 if we have an alpha value like that. We want to use ANOVA, so we can't, and that's perfect for this video because we're going to use Kruskal-Wallis. But what I recommend is just doing an if-else statement just to make sure all the time. And a lot of these videos, I'll just paste in the if-else statement. I'll type it out today. So what we'll have over here is if p-value Shapiro group 1 is less than 0.05, or, and we're going to do a classic 2, or, and then we're going to have 3. We're going to say or p-value Levene is less than 0.05. Oops. Meant to put a colon there. And then now I'll just paste the rest of this. We print data does not meet ANOVA assumptions, proceed with the Kruskal-Wallis test. Else, data meets ANOVA assumptions, consider using the one-way ANOVA, right? And it says data does not meet ANOVA assumptions. That's because we rejected the null hypothesis with Levene. And again, that is why, right? Either or, and we can proceed forward. So all we have to do now, instead of all this junk code up over here, like we can do this in one line. Why not? So we can have just over here stat, and we'll say p-value equals, and we'll have over here Kruskal, and then pass in each of our groups. So group 1, group 2, and then group 3, like that. And now we can print these out. So if we want to print out our test statistic, which is our h value, right? This is 4. And then if we want to print out our p-value, right, 0.13. And lastly, what we can do is print out our if-else statement. If p-value less than 0.5, significant difference found among the groups. Else, no significant difference found among the groups. And check this out, right? There's going to be no significant difference among the groups because our p-value over here is 0.13, which is much greater than our 0.05 alpha. So we fail to reject our null hypothesis. And literally, like I said, one line of code to run this actual test. But I highly recommend you just run Levene as well as Shapiro. Otherwise, I mean, you might as well run ANOVA for your data. But yeah, that's essentially it for the Kruskal-Wallis test. Thanks for checking out this video on the Kruskal-Wallis test. And if you found this video valuable, make sure to subscribe to the channel. We're uploading at least 3+ data science focused videos every single week. Now, if you want to learn even more about statistics with the help of Python, I linked a few videos that I think you would like down below in the description. And I have a playlist right over here for you guys to check out.